Thank you, everyone. AI is pervasive. AI is everywhere. The adoption is incredible. We don't listen often about AI and security. So I would like to have this conversation about AI and security. I would like to start first to clarify what we mean by AI and security, or security and AI. And I would like to ask Kris if you could explain the difference between using AI to secure products and services versus adding more security to AI.
Yeah, awesome. So we often hear about use cases for using AI for security: fraud detection, spam detection, detecting phishing attacks. But I think to create secure AI products, we really need to build security into the entire fabric of the products we're building. And we can use AI to help us determine where we can invest better. You know, at NVIDIA, we use AI for doing things like chip layout, anomaly detection, and things in our chips, but also for doing things like detecting, CVE vulnerabilities. But we really need to think at that next level: how do we build security in end-to-end in AI? Because no enterprises can really put AI into production unless they can trust the security of the entire product end-to-end. And every time you move data, which data is the key to AI, every time you move data, whether it be moving it from the database, whether it be moving it from the CPU to the GPU and back, every time you move data, there is potential for security risks and security holes.
So we all use smart devices. We all have AI in our phones, in our computers, in the cloud. Now, AI brings some questions. When we use smart devices, can we ensure that our privacy is respected? Can we trust the AI models in a device that they do what they claim they do? Can we ensure that the data, as you were mentioning, is protected and not compromised or corrupted in any way? I would like to start from Warden and then walk back. Can you all share your perspective on these concerns?
Yeah, and my biggest concern is for AI to be useful, it has to have access to all sorts of really personal data, audio, video, all of these things that are kind of coming in to kind of feed these models and make decisions. But if you've put a microphone and a camera in an everyday object and it's on, like they're on a lot of the time, you have this incredibly private data that's kind of suddenly sitting on the device. And we haven't really had this challenge before with this range of objects. And so trying to figure out how you can actually partition that raw sensor data so that you can use it for AI, but if somebody hacks your, TV, they're not going to be able to sort of watch you in your bedroom. Like that is really the architectural challenge I see here, is like how do we start treating this really useful data essentially as like toxic to the rest of the system?
I actually saw something on LinkedIn yesterday. I think it was like a new release of Claude, and someone had said, "Oh, you can now, it can operate my PC for me." And I was like, "Oh my God, please don't do that." So yeah, I think definitely there's that. Like when video cameras first came out, someone quickly invented the piece of plastic that you put over it. There is no sort of plastic equivalent to kind of contain the AI data yet.
Yeah, and I would say that it's the place where you can protect that personal data is at the ingestion. You have to keep that personal data from being fed into training for an AI. Once you contaminate a model with that data, it's basically impossible to surgically remove that, right? So we really have to have AI looking at all of our data to know where we have personal data, where we have sensitive data, what are the controls around that data, who has access to it. We've seen problems with people implementing RAG systems for AI, where you feed it, in massive amounts of data for your business, your specific data, and people didn't think about the access controls on that. One set of employees at a company may have, the rights to know about your new chip design,
Right.
but everybody at the company might not. If you feed that into, a RAG system, into your AI model, now potentially your model is answering questions that you don't want everybody who has access to that model to have access to.
Yeah, I think we're all saying a lot of the same things about, it comes down to trust. But then, how do you actually build that trust? Sort of with my hat of chair of the security committee for RISC-V, bringing it back to RISC-V a little bit, you need to have a way of giving assurance as a manufacturer or as a product provider. And can you give assurance to your users, to the final corporate client or the individual with the camera in their bedroom? You might want to put a plastic cover over that one. And to give that assurance, you have to use building blocks that we can provide in RISC-V. But also you have to use open standards. You have to be transparent. You have to have lots of good reviews and good process in place. And that's where RISC-V, I think, has an advantage in the sense that it's an open architecture. And open means well-reviewed. It means you're building systems with a huge resource of expertise. So it's not just one company in the corner with their security team. This is a community of experts, and it's a really huge community now in RISC-V, the security community. So Helena showed some of the standards and the numbers of groups that have been developed over the past 3 years, and it's been exponential growth. And so AI can now sit on top of all of these building blocks, and I think we can leverage all of these extensions and all the great work that we've done to give that assurance which lets you build trust. And I think that's really the key point for me is trust.
Yeah, I think like in the tinyML Foundation, we have so many companies innovating and building things, and we're all developers here. So when you first build it, the goal is to get it working, and then there's this issue of deploying it and commercializing it, and that's when you start to really need to think about the trust factors and security stuff. Ideally, and this is probably a great opportunity, I agree, for the RISC-V community, is how do you build like kind of a transparent and trusted pipeline for AI from the semiconductor all the way through to the services. Mm-hmm. And so that people that are building semiconductors, building devices, building solutions can all, snap to that pipeline and then even communicate out to the commercial buyers, people on the buy side or consumers, that this does snap to that kind of transparent pipeline for AI. So it's a real opportunity to do that, but it does require it to go from metal to cloud, on the security side.
And maybe I can, just on the practical level, one of the things we do is we actually hire outside firms to do audits of our end-to-end systems to try and make sure that we aren't leaking any private data, and having something like RISC-V with the transparency that you actually get to see into the hardware itself gives us another, even extra assurance that they can actually go in and they can double check what's actually going in at the really lowest level.
Well, one of the risks that I see is AI is moving so quickly. And people are very excited. People are building POCs. People are, putting things out there. But when we're building these products, we really need to step back and think first about security at the fundamental levels when we're building these things. Security can't be the afterthought. We really need to think about what is the hardware platform we're building on? What is our software infrastructure? Is it taking advantage of all these security extensions correctly, right? Because it's much harder to add the security as an afterthought than it is to build security into the entire fabric of the product from the beginning. So I know we're all excited. We all want to move fast. We all want to take advantage of AI. But I see tons of companies that build these POCs and they get dead-ended because there's too much security exposure, because there's too much risk that they involved. So I challenge everybody to think earlier in the process about how you build your AI for security from the hardware up.
And question for Pete Bernard, you have a very privileged viewpoint from the tinyML Foundation, your tech talks. You are in touch with everyone. Do you see a difference in behavior between Tiny IoT, Edge AI, or higher in terms of attention to security? Are the AI people, the security people, talking enough or not? What would you like to see?
Yeah, I mean, so we talk about AI in the real world. You know, that's kind of the world. That's what Edge AI is. It's AI in the real world where the data is created. And so there is an important level of security that needs to happen there just for any platform, regardless of AI, right? And you know, trusted boot and all that stuff. So, and these are systems that are in agriculture, in water systems, in healthcare. So pretty critical infrastructure in many cases. And so I think the community is pretty well versed in how to build secure kind of edge systems and IoT systems. The question is, what's the incremental that they should be doing at the beginning to secure, you know, AI workloads and training data and data at rest and data in motion. And I think that's still being figured out because a lot of that has to do with ML ops and the ML ops systems that are being used. Those are still pretty nascent when it comes to, I would say, like, let's say encrypting models and decrypting them on the platform. That stuff's pretty new. But the community knows how to build trusted endpoints. Now it's like, well, what's the extra effort I should do? You know, how do I do that, and who do I work with to secure the AI workloads? And then that's the special part. I think to maybe to Pete's point too is like, you know, what is the thing that's going to drive developers and providers of solutions to have these kind of transparent and trusted systems? Like, what is the forcing function? I mean, you can go out, like, I'm sure like the RFP from Chevron's going to say, here's my security requirements, but that's just Chevron. So what else is out there that's going to drive security, even for like consumer devices? I don't think Home Depot is going to put out an RFP on doorbells anytime soon. So, you know, they're just going to take whatever's in the box and put it on the end cap. So we as an industry need to sort of police ourselves and come up with ways of providing that kind of auditable, transparent kind of AI pipeline. It doesn't exist yet.
I think RISC-V is, the security community in RISC-V at least is trying to help the industry get to grips with this. So there's been a lot of work recently on what's called the security model, and the security model gives you, effectively, it's the recipe book, if you like, with all of the ingredients, and it can take you through from your asset identification, what is it you're trying to protect, through your threat models, who are the bad actors and just how clever are they in this case, and how you can map that onto the building blocks that RISC-V can give you, both in terms of open source software, things like SPDM, and the actual hardware extensions themselves, which we'll probably come on to. But it gives you that mapping, and that's really an important document. And I would encourage everybody to go take a look at that if they're starting off building an AI system that involves any kind of user privacy or user data. Then that, for me, would be a great starting point.
One practical thing, and this might actually be an ask for the community, is I/O pins. Cameras and microphones, you want to make sure that only certain very trusted parts of the software stack can get access to them. And that really isn't something that we've sort of thought about before or had, you know, we've always had open access to those. And we really need some verifiable security controls over who can actually access those.
So a secure data path.
Yeah.
That's a great segue. So there is a new extension.
Yeah.
It's almost like we planned this. In
Yeah.
actual fact, we don't. So there's a series of extensions coming called Cove, and there's one called Cove IO. And Cove IO lets you assign an external IO device to a confidential workload. So it's an open standard. It gives you the security controls. It's based on complete industry standards and PCIe, et cetera, and the like. But it does let you hook up your trusted sensor data just to your individual confidential workload, which is critical because that confidential workload may contain an attested secure private AI model that everybody's happy and comfortable with because it's been built with all of the wonderful security that RISC-V can give you. A little bit of a plug there. But unless you can also individually hook it to an external sensor and have a secure pipe, then who knows what else is running on that platform. And then it may get stolen. So Cove.io and Cove as the interfaces, or the Cove ABIs. So this is going to be ratified in the coming months. It's very new. And also it links into the what's called the SMMTT, which is the memory tracking tables or memory protection tables. And that's a building block that lets you effectively go from a trusted application in like an ARM trust zone kind of way, but different, obviously, because it's RISC-V, right through to confidential workloads, and where nobody trusts anybody, mutually distrusting confidential workloads. And all of these things are now being built or being ratified within RISC-V in the coming months. So we now have almost a complete toolkit now for exactly the problem that you just described.
Awesome.
That's really great to hear, because your entire system is only as secure as your weakest link, right? And so that's always been one of the scary parts about edge AI. It's so powerful, there's so much potential, but each one of those devices, if it's your weakest link, you could get access to your entire network, you know what I'm saying? And so it's really awesome to see what RISC-V is doing in this space.
I would like to look at AI also from a cost of investment perspective. Developing smart products, developing the AI models, the algorithms, the inference, training those algorithms is a huge cost, is a huge investment. How would you protect that? Is there a need to, and what would you like to see to protect that investment? Maybe we start from Warden, from building products, but also you have a long background in this.
So this actually came up a lot when I was at Google on TensorFlow. People being very concerned about them, safeguarding their models. And the first thing I would ask them is like, well, how are you safeguarding your binary executables? And, maybe there's some encryption or something like that that's happening before, but usually they weren't too worried about their binary executables, but they were very, very worried about their models. And I think in a lot of cases, you should just treat your models with the same level of protection that you treat your binary executable. And most people are like, if somebody wants to copy the binary executable, they probably can, but they'll have trouble kind of squeezing it in. So I actually tend to be on the very, very laissez-faire side of model encryption. Like maybe your model is this amazing rare unicorn that nobody else could ever use, but I think that's a lot rarer than people think it is.
Well, let me push a little bit on that. So I've had some projects when I was at Microsoft working with some fairly large, the Fortune 100s, and they would kind of characterize their models as really important IP for them. I worked with a lumber mill, and they had some AI models that they had developed to identify, flaws in lumber and things like that. So I think depending on the context, some of that stuff really is important IP that would want to be protected and encrypted. And I think the other thing that I've seen too, I was recently at a conference for aerospace, and we had the Lockheeds and everyone was kind of wringing their hands about AI, and in the aerospace world, it's very deterministic systems. And, then you throw in AI and it's very kind of funky. And so I think people were like, well, what about the provenance of the data set and the provenance of the model? And how do I ensure that that hasn't been messed with somewhere along the line in the data supply chain, right? How do we authenticate the data set that is training the model, and et cetera? So I think that's another area of opportunity for the community to figure out a way to protect that stuff too.
Well, and we see people worry about protecting their model, but often they forget, are you protecting your data set, right? Because if somebody can get a hold of the data set, they can recreate the model, right? And so they think so much about protecting their model, but make sure your data set isn't out there wide open on the internet in some public, bucket of bits, and ensure that you have a way to understand self-learning and what's being fed back into your AI, because models are becoming less static. More and more AI systems have, continuous feedback loops, reinforcement learning, exactly, right? And you have to be really careful that something negative isn't injected into your model. That's where we see bad actors are trying to jailbreak, and they're trying to corrupt models, just for the fun of it, right? Just to see if they can make it tell them how to build a fertilizer bomb, or whatever thing that they could put on the internet and say, hey, we made this model do this thing, right? So protect your data at all stages, at rest, in moving, but that's where these extensions in RISC-V and these things that we're adding to help along the way and make sure every stage of the pipeline is secure are super vital. So don't just think about protecting your already trained model. Protect your data used to create it, and protect the whole pipeline for the reinforcement learning.
I've seen model theft and cloning in the consumer space, where people just lift somebody else's model and drop it into their own product.
Yep.
And that does actually happen.
Yep.
And that's a really difficult thing to protect against. And also, some people monetize the delivery of the model or the upgrade of models. So there are camera systems where you can go and buy the latest automatic detection that's better at ignoring the cat when it will pick up the dog, etc. But monetizing that means you've got to deliver it, which means you've then got to have some kind of authentication of the device you're delivering it to, and then when it gets there, how do you stop it being extracted and cloned? All these things require a lot of careful thought and using open standards. But there are extensions in RISC-V that can help with this that are coming. So Richard Neal yesterday presented something on high assurance crypto, which lets you abstract away the key from software. So the keys to the models are never really visible to software. Yeah. They're handles, effectively. And so your confidential workload can be given access to a handle to a key, and that key can then deliver the private model data into protected memory. Nothing else can ever see that. And that's at a hardware level. So there's no real way to get away from, there's no way for another actor to get in from a software perspective and extract that key. So that helps a lot with anti-cloning and model delivery, but it's not a panacea. I go back to your point earlier about you have to plan this from the ground up. If you don't build it in from the get-go, then you can never retrofit this sort of level of security. It's impossible.
We've had some folks in the community also talk about like watermarking. Can we watermark data sets, to maintain the integrity of that data and find the provenance of that? And we have a lot of data sets contributed by the community, and and some people may say, well, that works for me, but I want to tweak it a little bit. And so then, okay, how do you sort of fork that and still maintain the last known good and know that no one messed with it? So I think that's going to be another area where people are sort of, the data provenance thing, I think, is going to be a hot area.
I mean, we could probably go off and spend an hour discussing the subtle advantages of signatures over watermarks and various threat models against them.
Is there an angle of applying signatures and watermark to the models as well, so that you have trust in the source of the model?
Yeah, most definitely. And attesting the runtime, because ultimately the way you use the model is also important. So the whole thing, it has to be end to end. So to Chris's point, it's everything that needs to be considered. Shutting the door after the horse has bolted, it's this.
Well, then also, what's the kind of external force that's doing the audit to verify that this is now a secure system from metal to cloud? That's also kind of a little bit missing.
Kris, you have a huge deployment of AI, of course, and we have just touched the point of runtime. How do we ensure that at runtime the code itself doesn't get compromised? Is there a runtime check or something?
Well, I think the community has been working a lot, the industry has been working a lot on this problem, right? Secure supply chain for your code, right? And so there's things like, attestation and confidential computing and things that, we're all working on together. But it is an ongoing problem, right? But that's where you need to build that in from the ground up. And I want to, everybody, we're talking about all the dangers and all the things here. I don't want to, everybody to come away from this scared of AI, because one of the points that we think of internally is every tool that bad actors can use to find holes, to infiltrate, every single one of those tools can actually be used on your products to help secure it and to help find those holes, right? So AI, can be used by the bad actors, but all of us can also use AI to build that next level of security, to do that next level of detection, and to make sure that our products are staying ahead of all of these bad actors.
Yeah, most definitely. There was an interesting talk from Google at RSA conference this year where they did some analysis and they seemed to think that actually this is really going to help the defenders in the arms race.
Yep.
It's going to help the defenders more than it's going to help the attackers, which
Exactly.
is great to hear, to be honest.
Yep.
We are reaching the end of our slot. We touched the point that RISC-V is a unique ecosystem where companies and members can contribute with their ideas. So as a call to action, I'd like to go through all our speakers, starting from Andrew. What's your call to action to have people come and participate to the security horizontal committee? What would you like to see as help, support, and from the pages?
So from a security and AI perspective, I would say it's help us build things like proof of concepts for secure boot, for attestation chains. It's get involved and engaged in open source proof of concepts that help us build these platforms, share, collaborate, get involved with RISE, get involved with the RISC-V security HC and the software groups. But it's all about having these open source components which are ready for others to use, that then they can be widely reviewed, they can be certified, they can be robust, and then we can all benefit from each other's work, I would say.
Any last word of wisdom?
Well, I think it's I would love to see more people, as they deploy edge AI solutions, market the security aspects of the platform,
right,
and highlight it and push their vendors and suppliers to have a really secure solution from end to end. I mean, that goes from the buy side, requiring it in RFPs, and people building on the semiconductor platform, the MLOps kind of middleware. Everyone needs to be part of the solution. So I would encourage people to think about that as a point of differentiation in the market.
I would just say, we need to work together strongly as a community. That's our strength. There are bad actors out there, but there is a lot of intelligence sitting in this room and at all of our companies that are part of the RISC-V Foundation. And I truly believe that if we come together and we focus on this, we can stay ahead of the bad actors. So collaborate, work together, bring your issues. Each one of us has a different perspective. Each one of our companies faces different challenges and sees different parts of the market. Bring those into the community and make sure we can work to solve them.
Yeah, and for me, it's really focusing on user privacy and making sure that we, because the near-term stuff is often about securing kind of our IP and sort of the stuff we care about as sort of engineers and manufacturers. But the biggest danger I see is not AI run amok, it's that we're creating this world where everything's spying on us because it's got a camera and a microphone, and we didn't engineer a way to actually prevent that. So really trying to think about securing all of that user private data is where I'd love to have people focused.
Thank you very much, everyone. I hope you enjoyed this conversation. I hope we are leaving you with the message that there are great minds making sure that our AI is secure. And I would like to thank our speakers as they made my life very easy. I think this was one of the easiest panels because you have all been great in interacting and making this work out. Thank you very much, everyone. Thank you.